Okay, hello, good morning. This is Mr. Ibrahim Romi, your science teacher for this year. I just want to welcome you for the first of your class in this first week. Today, our class today, we are going to refresh our information for the last we talked before about the element structure, and we said that the smallest unit of the element is called the atom, and the atom is consist of electrons in orbits rotate around the nucleus, and this nucleus contains positive charged protons and neutral particles called neutrons. And the atomic weight, it is the sum of protons and the sum of neutrons, and the atomic number is the number of protons in the nucleus or the number of the electrons. Okay, and we talked about the energy levels, and we said that each that each atom has energy levels, and the heaviest one have 7 energy levels. Maybe it have one, maybe two, maybe three, and the largest, the biggest one, the heaviest one have has 7 energy levels. Okay, I'm sorry. And we said how to do the electronic configuration. We have a rule called 2n power 2, and n is the number of the energy level. For example, the energy level number 1, so n equal 1, 2n equal 2, the third energy level equal 3, and so on. Okay, and this rule is not apply for this does not apply for energy level number 5, 6, and 7 because they all filled with 32 electrons only. And we talked about the valency, if the element entered the chemical reaction and it loses or gained electron, that amount or that number of electrons that gained or shared or lost is called the valency. And there are some elements in group called in gases or noble gases. They can't enter any chemical reaction because the outermost is filled with 8 electrons, so their valency equal to 0. Okay, and we called about the types of elements: metals, and metalloid, and the non-metals and energetics. Today we are going to study in this lesson the modern periodic table or the periodic table. But before you, for example, do you know the pyramids of Egypt? Before you know, when you want to know how these pyramids built, you need to study their study, and we are going to study this table this year. So we are going to need to know the history of the building or the history of constructions of this periodic, okay, of this periodic table. So we are going to study the history and the attempts for creating this table. All right. At the first, you want to know how many elements are existed in our life now. There are 118 elements in nature. They are different in their properties and chemical and physical structure too, physical and chemical reactions too. Okay, and maybe you heard that before in your last year that the number of elements were 118 elements, but in the attempts of element classification and the history of building the periodic table, the number of elements were less than this because they discovered over the years. Okay, so maybe the number of elements you will found a little bit. I'm sorry. You will found a little bit less than this because they discovered the new elements over years. Okay, so the first attempt for elements classification is called Mendeleev's periodic table, and the second one is called is called Mosley's periodic table, and the third one and the final one is the modern periodic table. Okay, and in this lesson we are going to talk about the first and the second and the third lesson. All right. Maybe you ask yourself, why the scientists classify these elements in a periodic table, or according to anything, according to their properties, or according to their atomic weight or atomic number, in order to facilitate their studies and to find the relationship between elements and their chemical and physical properties. Can you imagine with me here in this table, why are we putting silicon after carbon? Why not we put phosphorus, for example, here, and we put silicon here? We classify these elements, and you are going to study this. We classify these elements in one group that they have the same properties. For example, if we are making the car wheels or the car tires from carbon, and the carbon element suddenly happened, it's not existed on Earth. So what is the alternative one? What is the alternative element for this carbon? The element that come after it, and it's a silicon. So it helps us to find the relationship between the elements and each other and their chemical and physical properties. So the carbon uh, maybe carry the friction force, and maybe the silicon do the same. So they have the same physical properties. Okay, so that's how, or that's why scientists classify elements according to their properties and the periodic table to facilitate their study and to find the relationship between their chemical and physical properties. Okay. The first attempt is called Mendeleev's periodic table, and we are going to know for today uh, what what this attempt, and we are going to know some information about Mendeleev. Mendeleev's periodic table. He was a Russian scientist, and the first this periodic table, the periodic table of Mendeleev, was the first real periodic table in history. So, so in the test, if you have complete and told you the first real periodic table for who from this one, and you have to write Mendeleev. Mendeleev's periodic table was the first real periodic table for classifying elements. At that time, how many elements were existed? There were only 67 elements we know, not 118 like now. They were less than this, okay? Because that happened in past, that happened in the past. And Mendeleev, uh, there is another thing here. Mendeleev wrote his periodic table in a book called Principles of Chemistry in the year 1971. Okay, how Mendeleev classified the elements in his table. At the first, he prepared 67 cards, each card for an element. So we have 67 cards for 67 elements. Okay, and then he wrote over that card the name of the element and the atomic weight and some important properties like the boiling point and the melting point and the density. For example, this card, and he wrote the symbol of the element too. For example, at this card, but this card was not for Mendeleev; it was for Muslim, because here supposed to write atomic weight, not atomic number. Okay, so let's just pretend that this atomic number, he wrote the name and the symbol and the atomic number and some properties like the density and the melting point and the boiling point. Okay, so that the second step that he has done. Okay, so he has done two things right until now. He prepared 67 cards. Each card represents an element for 67 elements. Each card, he wrote the name of that element and the symbol of it and the atomic weight of that element and some important properties the atomic, like the like the melting point and the boiling point and the density. Okay, The third of this, when he was writing the properties of these elements, he notes that there some elements have the same elements. They are similar and they have the same properties. They are similar in their properties. So he arranged that elements that have the same properties, that have the similar properties in vertical columns like this. Lithium and carbon and fluorine have the same properties, so they arranged them in vertical columns, and this vertical columns known later as groups. Okay, so this group number one, group one, group two, group three. Okay, why he arranged hydrogen and boron and oxygen after each other? Because they have the similar properties, and these ones have similar properties, and these ones have their similar properties. Okay, and and he discovered too that there's some elements have the same properties of this one, but they different in somehow. For example, they are similar in melting point and the density, but they are different in boiling point. So what are he going to put them? He are going to do another thing, which are he's going to make sub-level. He's going to classify that main level into two sub-levels. Okay, for example, that group A, he will he will uh, he will classify that group A into two subgroups, group A1 and group A2, because A1 and A2 have different properties than the main group, which is group A. Okay, so here he arranged the elements that they have the similar properties in vertical columns, which were known later, which is called as groups. So here a main group one, main group two, a main group three. Okay, and then he found here some different properties for some new elements, but he's not going to do it. But he's not going to put it in the main group. He's going to classify it to two subgroups, as here he classified that one into two subgroups, one and two. Okay, because there some elements have different properties. And then when he was doing this classification or this arrangement, he notes that there an increasing in the atomic weight from the left to right. For example, here 1, 2, 3, 4, 5, 6. So 1, 2, 3, there is an increasing from left to right in the atomic weight. So he arranged the elements in an ascending order according to the atomic weight. Like you see here, sodium has 22, um, magnesium has 24, so 22, 24, 26, 28. There is an increasing in the atomic weight. So he arranges them in ascending order according to their atomic weight, from left to right, as you see in this picture. In what? In vertical columns? No, in vertical columns, we arranged them before according to the similar properties, which were known as groups. But here he arranged them in ascending order in horizontal rows, and this horizontal rows called periods. So this picture, we have vertical columns called groups, and we have horizontal rows called periods. Okay, and the number of the atomic weight increase from left to right in an uniform way. Mendeleev's periodic table have advantages and disadvantages. That was what Mendeleev did for his periodic table. So let's talk about the advantages of his table and the disadvantages. The advantages, when he was arranging the elements in an ascending order, he found that there is an increasing from left to right, 1, 2, 3. But he found that he had the element 1, 2, 3, 5. So where is the element number 4? So maybe they are going to discover it later. So I will leave an empty cell for that new discovery element, and that was correct because the scientists had discovered new elements after his periodic table. So that his prediction was quite correct, because he predicted that they are going to discover new elements, and that happened, of course. So the first advantage is that he left empty cells in his table, predicting the discovery of new elements. The second advantage that he corrected some atomic weight. He was dealing with the atomic weights of elements, and the scientists before him were estimate this atomic weight of some elements wrongly. So he corrected that atomic weight into their correct one. For example, lithium, he corrected lithium atomic weight from 6 to 6.9. Okay. Disadvantages of Mendeleev's table, and that is the last thing for our class today, that he has to put the elements of the same properties in one group, and of course he has to put the same elements according to atomic weight in ascending order from left to right in horizontal row. So he has to deal with the vertical columns and the horizontal rows. So he made some disturbance in the ascending order, just to put the elements in one group according to their properties. Okay, so he made some disturbance in the atomic weight, just in order to classify the elements and to put them in one group according to their properties. The last disadvantages, that he had to deal with the isotopes. The isotopes is a concept for an element who has more neutrons or more protons. Okay, so if we have that element here, he has electron and proton and neutron. Okay, so he is natural. What happens if he is become radioactive? He has more neutrons, so the atomic weight of this elements will change. He will have, instead of one, he will have two. Maybe he will have three. So, but all of them are for the same element. But Mendeleev dealt with these isotopes as they are different elements, not for one element. Because what? Because he said that they have different atomic weight. For example, here one, two, three, so they are different. They are different elements, and that was wrong because all of them are for the same element. Okay, that was for today. And just 1 second, I want to solve some questions with you before I close the class. Okay, here Mendeleev had how many cards? He had 67 cards. Each card represents an element. Okay, element of similar properties in vertical columns, which were known later as groups. And the similar properties. Okay, similar properties. So they are called groups. Okay, elements arranged in an ascending order according to the atomic weight. So atomic weight. So it's periods. Okay. Choose the correct answer. The first question is the elements of each main groups into two subgroups. How many attempts to classify elements? There were 3 attempts to classify elements. Mendeleev's book called, I told you the Mendeleev's book, it was called Principles of Chemistry. Okay. That was for today. I hope that you are enjoying the lessons and I hope that you make it correctly. Please don't forget to read your document and to solve your homework. And if you need any questions, just write a comment for me and I will answer you directly. Okay. See you next time, and I hope that you are in good health. Goodbye.